Assalamu alaikum, my dear student. Today our topic it is Gauss Divergence Theorem. Gauss Divergence Theorem we consider as relation between the surface and the volume integral. With the help of diagram, we study about the Gauss Divergence Theorem. Student, when we consider three dimension, it means when we consider the sphere, z is equals to g1 of xy, z is equals to g2 of xy. These are the surfaces. There are three surfaces. We have seen that sigma 1, sigma 2, sigma 3, and R is the region. In the second diagram, student, so when we determine the value of integral, z is equals to g1 of xy, z is equals to g2 of xy, from this part to this part, capital G represent here the general region. So the theorem of divergence theorem, let G be a solid whose surface sigma is oriented outward if f of x, y, z, which is equals to f of x, y, z of I plus g of x, y, z of j plus h of x, y, z of k. Here small f, g and h have continuous first order partial derivative on some open sets containing g, and if n is the outward unit normal on sigma. So student, what we call it outward normal. Outward normal represent here, student. If we draw for example, if we consider the surface, this is called outward normal, and if the downward position, the normal, and the perpendicular line on the surface, it is inward normal. This is called outward normal. So inward normal and outward normal, the directions are opposite. So if n is the outward unit normal on sigma, sigma consider here oriented outward surface. So according to theorem, double integral sigma f dot n ds, which is equals to triple G divergence of f into dv. So student, first we find when we consider the first function f of x, y, z I dot n, which is equals to in triple integral g dava f upon dava x into dv, and we find the partial derivative with respect to x into dv. It means both are equal when we find out. So sigma integral, double integral sigma g of x, y, z of the given function, second function with respect of j dot n ds, which is equals to triple integral g, when we find the partial derivative dava g upon dava v dava y into dv, and double integral sigma h of x, y, z of k dot n ds, which is equals to dava h upon dava h upon dava z into dv. So student, when we find the double integral convert into triple integral, we applying this condition when after finding the divergence of f. So start now. First application about use divergence theorem to find the outward flux of the vector field. So and we have given vector field. So when we consider f of x, y, z is equals to, so we start now, let sigma be the oriented outward spherical surface G is encloses region so the divergence of vector field is del dot F, which is equals to dou over dou Z into Z of means student dou over dou xi plus dou over dou yj plus dou over dou zk into f. F is z of k. So when we find the derivative with respect to z, it means dou z upon dou z, it means 1, or k dot k it is 1. So the divergence of f it is 1. But when if you find dou z upon dou x it is 0, dou z upon dou y it is 0, and dou z upon dou z it is 1, and k dot k it is 1. And we find the so first we find student divergence f, then the flux across sigma, the flux across sigma is phi is equals to phi represent here flux double integral sigma f dot n ds, which is equals to triple integral g del dot f into dv, and del dot f it is 1, so triple integral g, which is equals to dv. So it means the volume of g is equals to phi is equals to volume of g according to sphere definition, it is 4 pi a cube upon 3. Now student, after that we will find what is r phi of theta, because you know very well x square plus y square plus z square, which is equals to a square, and what is x? X is in sphere spherical coordinates of x, it is this is the equation of sphere student. So now the coordinate of spheres are a sine phi cos theta of I plus the coordinate of y it is a sine phi sine theta of j plus a cos phi of k. So these are the coordinates of spheres in spherical coordinates. These are, and the phi is 0 to 2 pi, 0 to pi, and theta is 0 to 2 pi. So the limit of phi is 0 to pi, and the limit of theta is 0 to 2 pi. So student, first we find dava r upon dava phi into dava r upon dava theta, which is equals to a square sine square phi cos theta of I plus a square sine square phi sine theta of j plus a square sine phi cos phi of k. And we find the cross product after the derivative dava r upon dava this. So if we multiplying f dot dava r upon dava phi into dava r upon dava theta, which is equals to a cos phi of k into a square sine square phi cos theta of I plus a square sine square of phi of sine theta of j plus a square sine phi cos phi of k. When we find that cross dot product, it means when we multiplying each and now the remaining term, it should be 0. So the answer it is a cube sine phi cos square phi. The student, we have determined dava r upon dava phi into dava r upon dava theta. So now therefore phi is equals to, you know very well, sigma is sigma dot so which is equals to a cube sine phi cos square phi. After that, we define you, therefore phi is equals to double integral sigma f dot n into ds, which is equals to double integral r f dot dava r upon dava phi into dava r upon dava theta, into dA. So student, double integral sigma f dot n ds we will convert into in this form. Then we find the integral value. So therefore, the theta phi is 0 to pi, and the limit of theta it is 0 to 2 pi. So theta to 0 to 2 pi, and the phi is 0 to pi. What is f dot r? It means this value we will convert in. We will put here a cube sine phi cos square phi into d phi into d theta. So the derivative of cos, it is sine minus sine. So we will applying the negative sign on both sides, and the integral of cos square phi, it means cos cube phi. A cube is a constant, so we write on the before the integral the theta limit from 0 to 2 pi, and after integration we will put that we are applying the limit 0 to pi. So cos phi is minus 1 cube minus into 1 0. Cos 0 is 1, so it is 1 into d theta 0 to 2 pi minus a cube. So the student, the answer it is minus 1 into d theta 0 to 2 pi. So when we add both of them, minus 2 minus minus plus 2 times of a cube, integral from theta, integrate, theta is 0 to 2 pi. So it means 2 times of a cube 2 pi minus 0, it means 4 times of a cube pi. So the integral value it is 1 upon 3. The next step, so minus 3. So it means it is 2 upon 3. Hence, phi is equals to 4 upon 3 a cube pi. This is called outward flux. So we have determined. So we will continue, and the next application, student, it is a cubic shape. These are the direction of the outward normal, outward flux. It means all these direction represent here the outward flux, because the vector is perpendicular on the surface. This is called the outward flux. So student, according to definition, let sigma denote the outward flux of the cube and G is the enclosed region the divergence of vector field is, so student, first we find del dot f. Del is dava over dava xi plus dava over dava yj plus dava z over dava k dava dava zk into the function f of x yz. So we write here 2xi plus 3 times of phi of j plus z square k. So first we find the partial derivative with respect to x. It is 2, it is 3, I dot I it is 1, and the derivative it is 2z. So it means we write here k dot k it is 1. So the answer it is 5 plus 2z. First we find the divergence, it means del dot f. So according to definition, student, outward flux represented by phi, which is equals to double integral s sigma f dot n ds, which is equals to double integral g del dot f into dv. This is the formula of outward flux when we convert the surface integral into volume integral. So we will find easily the value of cube. It means when the value of x is 0 to 1 and y is 0 to 1, x is 0 to 1 and z is 0 to 1. So when we consider the cube, because so the value of the limit of x and z, so limit of z is 0 to 1, the limit of 0 to y is 0 to 1 and the limit of x is 0 to 1. Del dot f it is student 5 plus 2z we have determined in the previous step. Then into dv, dv is equals to dz into dy into dx. First we integrate with respect to x, 5z plus z square. Then we are applying the limit 0 to 1 into dy into dx. The limit from 0 to 1. So it means 5 plus z square, it means 5 plus 1 is 6. 6 outside the integral because it is constant. So then in the next step we will integrate with respect to y. So y is 0 to 1 and the limit of x is 0 to 1 into dx. So student, we will continue and find the integral value. So when we put here applying limit in terms of I, 1 minus 0, it means 1. So 6 again as it is, and the integral is 0 to 1 into dx. In the next step, we will integrate x. It means 6 into 1 minus 0, it is 6. So therefore, student, phi is equals to 6. We have determined. This is called outward flux of a cube. F dot n is constant on each of the 6 faces of cube, because cube has 6 faces. So that's why our outer flux it is 6. So these are the applications about when we applying the divergence theorem. Now the next application is when use divergence theorem to find the outward flux of the vector field. These are the direction. It is hemisphere. This shape represent here the hemisphere. And the equation of hemisphere they are given z is equals to, it means it is a function with the help of sigma is the spherical surface integral, and the limit of x is 0 to a, y is 0 to a. It means it is the radius of the circle. So start now, student. Let sigma denote the next sigma denote the outward oriented surface and G is encloses region so the divergence of vector field is del dot f. It means divergence of f, which is equals to dava over dava xi plus dava over dava yj plus dava over dava zk. What is f? F you have given in the question. It means x cube I plus y cube j plus z cube k. When we taking the dot product, student, with respect to x, if you find the derivative, it is 3x square. I dot I it is 1 plus the derivative of y cube means 3y square, and the derivative of z cube of partial derivative with respect to z it is 3 times of z square. I dot I it is 1, k dot j it is 1, and k dot k it is 1. When we take in common in whole term, so it means 3 times of x square plus y square plus z square. So therefore, according to divergence theorem, student, double integral sigma f dot n ds, it will be equal to, in the volume integral, g divergence of f into dv. Because this equation represent here, student, it is a spherical, it is the equation of a sphere. So as you know that x square plus y square plus z square is equals to a square. As you know very well, according to sphere equation, this equation is called a sphere equation. So here we applying, before find the integral value on the right hand side. So we will convert into spherical Cartesian coordinate, convert into spherical coordinates. So what is x in which is equals to sigma square so using spherical coordinates x is equals to a sine phi cos theta, y is equals to a sine phi sine theta. These are the spherical coordinates. When we convert Cartesian coordinate into spherical coordinate, z is equals to a times of cos phi. And dv is equals to, student, del dot f is equals to 3 times of x square plus y square plus z square, because it is equals to sigma rho square. So it is 3 times of rho square, and dv is equals to, in spherical coordinates, it is equals to rho square sine phi into d rho d phi into d theta. Now therefore, phi is equals to triple integral g. The limit of theta is, when we integrate with respect to rho, it is 0 to a, and the limit of phi is 0 to pi by 2, 0 to pi by 2, and the limit of theta is 0 to pi. When we convert it into spherical coordinates, so the student, it is 3 times of rho square into rho square sine phi into d rho d phi d theta. Rho square into rho square, it means rho 4. Sine phi is a constant, so we outside the integral. So rho phi into d phi. Now the remaining constant is right here. First we integrate with respect to rho. The limit of rho is 0 to a, and theta is phi is 0 to pi by 2, and theta is 0 to pi. So we will integrate rho 5 upon 5. Then we are applying the limit 0 to a sine phi d phi into d theta, and the limit of theta phi is 0 to pi by 2, and the theta limit of theta is 0 to 2 pi. So when we put here student a5 over 5, so it means 3 upon 5 a5 sine phi into d phi in the next integral, when we integrate with respect to phi into d theta, theta phi is 0 to pi by 2, and theta is 0 to 2 pi. Now student, integrate the integral of sine, it is minus cos phi, the limit from 0 to pi by 2, and minus 3 upon a5 . So when we put here student cos 90, it is 0. So 0 minus cos 0, it is 1 into d theta. So the answer it is, in the next step we will return. So it is minus 3 upon 5 a raised to the power 5. Cos 90 is 0, 0 minus 1 is minus 1 into d theta, the integral from 0 to 2 pi. So instead when we integrate, minus minus plus 3 upon 5 a5 theta 0 to 2 pi. So it means 3 upon 5 a5 into 2 pi. When we are applying the limits, so 3 to the 6, 6 upon 5 a power 5 into pi. This is called outward flux. So therefore, phi is equals to 6 upon 5 a raised to the power 5. This is for all. So today we will learn about, student, what is divergence theorem. Use divergence theorem to find the outward flux of the different application when we consider. So thank you very much. Take care. God bless you. Allah Hafiz.